All right, so you also don't forget to finish up 49. You're going to have to distribute and then solve. All right, so this is the beginning of fall final exam number 4 video, covering numbers 49 through 63. I'm not doing all of them, but I'm doing a few of them to make sure you guys understand what you're asked. So looking at number 50, it says solve each equation by clearing the fractions and then state the excluded values. Now remember, excluded values avoid leading to a denominator of 0. So we have to make sure that we're not dividing by 0, because anything divided by 0 is undefined, and it would even read an error on your calculator. So let's look at number 50. So what I know down here is that this value cannot equal 0, because otherwise if it did, it would be 2 divided by 0, which would read error on your calculator. So we cannot have a 0 in the denominator, so we have to have excluded values. So the way we find those excluded values is, think about it. What plus 3 would lead to a 0 down here? Well, what's the opposite of a positive 3? The opposite of a positive 3 is a negative 3. So what we would end up having is r could not equal negative 3. Because if I plugged in a negative 3 for r, negative 3 plus 3 would give me a 0 in the denominator. So basically, whenever you have a variable in the denominator, you should have an excluded value. So, and only in the denominator. You can have a variable in the numerator, just not in the denominator. So the way I'm now going to solve this is I'm going to use the cross product. So I'm going to multiply 2 times 3, which is equal to the other cross product, which is going to be 4 times the quantity of r plus 3. So it's probably best to put parentheses around expressions. So 4 times the quantity of r plus 3. So now I'm going to simplify. So I get 2 times 3 is 6. 4 times r is 4r. 4 times 3 is a positive 12. From here, I could just solve for r by subtracting 12 from each side. And I get a negative 6 equals 4r. So I'm going to take this over to the side. I get 4r equals negative 6. Divide out the 4 to get r equals, divide by 2, a negative 3 over 2. And there is your final answer. Make sure that your excluded value is not the same as this, because if so, then you made a mistake. All right, so negative 3 over 2 is different from your excluded value, so we can accept this as a solution. All right, let's take a look at number 50. Okay, so likewise, in this example, though, because you have constants in the denominator, then you do not have any excluded values. It's only when you have a variable in the denominator, because we want to avoid a denominator of 0. So what this means is now we can just solve by finding the cross product. But I'm going to go ahead and put parentheses around here so you guys know that you will be utilizing the distributive property when you multiply this by the 6. So we're going to go ahead and write that out as 6 times the quantity of x minus 3, which equals the other cross product, which is 4 times 5. 4 times 5 is simply just 20, and I'm going to go ahead and put that in there. So now I'm just going to distribute the 6. So I get 6 times x, which is 6x, and then 6 times a negative 3, which is a negative 18, which equals 20. So now I just want to get the variable term by itself. That's the goal. So I need to get rid of the negative 18. So in order to get rid of the negative 18, I add the opposite. What I do to one side, I do to the other. Always have to be fair in math. So now I'm going to squeeze this over here, and I'm left with 6x, which equals 20 plus 18 is 38. And now I'm going to divide both sides by 6. And I get x equals, all I could do is reduce over here by 2. So when I go 38 divided by 2, that gives me 19. And 6 divided by 2 is 3. And this is your final answer, 19 over 3. All right, let's go ahead and look at number 54. All right, so now looking at number 54, while I'm doing evens, the point is that you do an odd and then come back with me and practice an even just to make sure you're on track. So now we're back to where we have a variable in the denominator. So we got to make sure v isn't a certain value. That leads to a 0 down here. So what minus 3 would give you 0? Well, hopefully you see that 3 minus 3 would give you a 0 here. So we're going to say that v cannot equal 3. And that's our excluded value. Having a 5 down here is a constant. Nothing's going to change the value. So now I can just put parentheses around this and solve by cross product. So I'm going to v minus 3. So 3, sorry, that looks horrible. So 3 times the quantity of v minus 3, which equals the other quantity of 2 times 5, which is 10. So kind of butterfly method, as one might say. So now we distribute. Hey, where did my screen go? There it is. All right, so I'm going to distribute. 3 times v is 3v. 3 times a negative 3 is a negative 9, which is 10. Now I'm going to go ahead and solve for v by isolating the term that contains the variable. So I'm going to add 9 to both sides. So I'm left with 3v equals 10 plus 9, which is 19. And don't be afraid if you get a fraction as an answer. It's okay. So we get v equals 19 over 3. All right. So feel free to pause it, try number 55, and then come meet up with me at number 56. I'm going to actually do 57 since 56 is about the same that we've been working on. The reason I want to point out number 57 is you might get something like this where they're trying to say, is there an excluded value? But because there's a variable up top, it's okay. You just can't have them in the bottom. So don't let them think that because you see a variable, there's an excluded value of negative 6. That's not true. Only down here in the bottom. So because we have constants, there is no excluded value. So I'm going to go ahead and solve by putting parentheses around here and then finding the cross product. So what I get is 3 times the quantity of p plus 6 is equal to the other cross product of 6, 2, which is 12. So I'm going to distribute and get 3p, 3 to 6 is 18, which equals 12. So I'm going to subtract 18 from each side, and I get 3p equals negative 6. So these cancel out, bring down the 3p, bring down the equal sign. 12 minus 18 is 6. Now just divide by 3 on both sides to get p equals negative 2. And you're set. All right, so all of these are pretty much the same. We'll go ahead and jump. But again, as soon as you're done with this, go back and finish these problems because I'm only doing a few with you guys. So here, again, I'm going to use the cross product n plus 3 times 4. I like to put the 4 first and then distribute, just my personal preference. And then I'm going to go 2 times 5, which is 10. Now I'm going to distribute. 4 times n is 4n. 4 times 3 is a positive 12, which equals 10. So now I have my variable term here, so I just want to get rid of the constant, so I'm going to subtract 12 on each side. So I get 4n equals 10 minus 12, which equals a negative 2. And now I'm going to divide both sides by 4 to get n by itself. And I get n equals negative 2/4, which simplifies to negative 1/2. All right. All right, in 60 through 71 practice. So solve each inequality and graph its solutions in interval notation. So let's go ahead and start with the evens. Okay, when we're solving inequalities, all we're doing is treating them like they're equations, except we're going to adhere to the inequality as to find the infinite number of solutions that are here. So what I'm going to do is get x by itself by adding 6 to each side. What I do to one side, I do to the other. And now 6 minus 13 is a negative, whoops, 7, where's my, there we go, sorry. So 6 minus 13 is a negative 7. And then now I have this inequality that reads x is greater than or equal to negative 7. So at negative 7, I can go plot a point. It's going to be a closed circle. Because there's x can equal negative 7, I show that by shading in the circle. And then x can be any number greater than negative 7, which is going to be towards positive infinity. So when I go to write an interval notation, because I write from least to greatest, from left to right. So at negative 7, it's included, so I show that by using a bracket. Parentheses represent values that are excluded. And then it goes to positive infinity, and we use parentheses always with infinity symbols. All right, so let's take a look at 62. Now, n divided by 16 is less than 14. So I'm going to clear the division of 16 by multiplying it out. So multiply each side by 16. What I do to one side, I do to the other. These now cancel out, and I'm left with the statement n is less than 14 times 16. So 14 times 16 is 224. So here's my open circle at 224 because n has to be less than 224. It cannot equal. So I'm going to go anything less than is towards negative infinity. So to write this in interval notation, I write from least to greatest, left to right. So from the furthest left, I have a negative infinity symbol all the way to 224, which is also a parenthesis. All right, so let's go ahead and we'll do 63 and call it a day with video number, what is this? This is going to be video number 4. All right, so looking here, I'm going to go ahead and clear the fraction by multiplying by the LCM. The LCM in this case is 6. So I'm going to multiply this side by 6 and this side by 6. So we see that 6 times 1 is 6 all over 2. So we get 6 all over 2, which is less than n. But what is 6 divided by 2? 6 divided by 2 simplifies to 3. So we get the statement 3 is less than n. So to graph this, at 3 it's going to be an open circle. So if I want to know, do I go to the right or to the left? Because I can't take the direction that this is pointing because the variable is on the right side. So 3 is less than n. Well, give me a number that's more than 3. So let's say 4. Is 3 less than 4? Yes, so 4 is a solution. So that tells me I'm going to go towards 4, which is going to be towards positive infinity. So my solutions are going to be an interval notation from 3 to positive infinity. Now, if you want to make sure that you're correct on your solution, if you don't like it like this, because we don't read backwards, we could flip the n, flip the 3, which means we flip the sign. So we could also read this as switch n, switch 3, switch sign. So now you could clearly see that it's going to the right towards positive infinity. All right, so that concludes video number 4. Go ahead and make sure you complete all of these examples.